All right, let's see now how to run a repeated measures ANOVA. The repeated measures ANOVA, we do it whenever we have multiple measurements in one group. So I have a group that I measure 3 times at least. So I open up my data set, repeated measures ANOVA, and there it is. So I have one group of participants. In this case, I have 18. They are measured at week 0, week 3, and week 6. So to run a repeated measures ANOVA, I just click ANOVA, repeated measures ANOVA. I add one level here because I have three measurements. I have week 0, week 3, and week 6. And here the software runs the results. As we can see, there is a main effect of the in this case it's called factor, and is whose p is less than 0.001. What I have to do, what I can also do is also to estimate the effect size, and what we call eta square, and the eta square is 0.92, which is pretty strong. Now the other step now, since I have to do the post hoc analysis because my main effect is telling me that there is a main effect, and because it's lower than 0.001, I can run the sphericity test and see which is the p-value of the sphericity. The sphericity test says that sphericity is violated because the p-value is less than 0.05. Just remember that if data are normally distributed, the Mauchly W p-value, which is this, in the sphericity test is higher than 0.05. If it's lower, then there is a violation of sphericity, so data are not normally distributed. So what I have to do is to look at the Greenhouse-Gieser here error, or Greenhouse-Gieser test. So if the p-value is less than 0.05, so sphericity is violated, I look at the Greenhouse-Gieser. If the Greenhouse-Gieser value is higher than 0.75, I have to apply the Hunfeld correction here. If it's lower than 0.75, I have to apply the Greenhouse-Gieser correction. So in this case, it's lower than 0.75. So what I apply is the Greenhouse-Gieser correction. So I apply that, and I run my post hoc test. There. And the correction that I do is the Bonferroni correction. So here I have already the p-value Bonferroni corrected, but also corrected by the sphericity, okay? And in this case, I applied the Greenhouse-Gieser sphericity. If I had no, if the sphericity assumption was met, so the p-value here was higher than 0.05, I don't apply any sphericity correction, and I just click none, okay? That's it. But since it is, and the sphericity is violated, I have to apply my Greenhouse-Gieser correction, okay? And these are the comparisons. So you can see from here that level 1 is different than level 2, because the p-value is less than 0.05. Level 1 is different than level 3, and level 2 and level 3 are equal, more or less. You can find the mean difference here. So in this case, you can see that the level 1 is higher than level 2, level 1 is higher than level 3, okay, because these two numbers are positive. Level 2 and level 3, they are almost similar because it's 0.063, so we are almost at 0. Again, you can run the descriptive plots, which show you the, let me see, we show you the plot of the 3 levels. Okay, very nice. And again, you can run the rain cloud plot, and you can put it in the horizontal axis, and you can have this very, very beautiful graph. I don't know what happens if you put it here. Nothing. Okay, so these are the data point. So each point is one subject that does measure 1, measure 2, measure 3, and the lines connect the data of each subject, you see. And it's very nice to see the individual data plotted here in this plot. Okay. So I think that's it for the repeated measures ANOVA. The thing that you have to keep in mind is that it's done when you have one group measure more than 2 times, so at least 3 times.